everyone, in this video we will be solving system of equations using substitution method. This is the fourth part. I will put the link of the first, second, and third part in the description box below. So let's take this example right here. So we're supposed to solve this system of equation right here. There are steps that we need to follow in order that we can solve system of equations using substitution method. The first step is to substitute or plug in one of the equations to the other equations and solve for the first variable. Now, looking at this equation that we have here, we can plug in this y squared minus 13 in replacement of the x. However, this is raised to the power 2. So this would give us y to the fourth power. Now, we can go ahead and isolate y squared by itself so that once we have y squared, we can plug that over here. So then I can go ahead and change this into this form. So that's going to be plus 13 and plus 13. So I am left with x plus 13 equals y squared. So what I did was I just change this form so that y squared is isolated by itself, so that this is equivalent to this equation. So these two equations right here are equivalent equations. So then we can go ahead and say that this equation right here can be changed as y squared is equal to x plus 13. Again, these two are equivalent. I just have y squared by itself. So what's going on right now is that we will be working on these two equations since we already changed it. Since we already isolated y squared by itself. So I have prepared a card here. So the card looks like this. So what I did was I copied x squared plus y squared equals 25. Y squared is equals to x plus 13. Since we say that y squared is equal to x plus 13, and in the first equation we have y squared. So what I can do is I can grab this x plus 13, since this is equal to y squared. I will cover this y squared since these two are equal, they're the same, and since this y squared is equal to x plus 13, so I can go ahead and grab this and cover that whole thing. And this will be the equation that we are going to work on with so that it's so that we're able to solve for x. So what's gonna happen here is that from here, what I did was I actually took this x plus 13. I will use the substitution method. Substitution means I plug in. So I will plug this into the y squared since that is equal to y squared. So that's what I did. So our working equation would already become, that's gonna be x squared. So it's pretty much this one. Plus, and then since they are together, they're all in purple color, so I can go ahead and just write x plus 13, and then that is equal to 25. So then from here, we distribute the plus to each of the terms inside the parentheses. So I distribute this, and I distribute the plus to the other one as well. So then we are left with x squared plus x plus 13 equals 25. So then we go ahead and solve for this equation right here. Remember, if we want to use the zero product property, we need to make one side equal to 0. So I can go ahead and subtract 25 from both sides, minus 25. So then we are left with, this is going to come out x squared plus x. That's going to be minus 12, because that's 13 minus 25 is negative 12, and that is equal to 0. So then from here, we are going to use the box and diamond to factor this out, and I'm going to show the box and diamond method up here on how we can factor this. So this is how it's going to look like. Okay, so the factors for this would be, that's going to come out x plus 4 and that's gonna be x minus 3 equals 0. And then from here, we can use the zero product property so that we can solve for x. And I'm gonna show the work up here using the zero product property. So this would come out, that's gonna be x plus 4, and then that's x minus 3 is equal to 0. So I can go ahead and equal both of them to 0. So that's x plus 4 equals 0, and x minus 3 equals 0. So then the first one, I'm gonna subtract 4 from both sides, minus 4. So then the first x is equal to negative 4. So this is the first value of x, and the second value of x would be plus 3 and plus 3. So then I go ahead and cross this out, so we're left with x is equal to 3. So these are the two x values that would work for these two equations right here. Now again, this is the first step. Now we are ready to move on to the second step. The second step is to solve for the second variable by plugging in the values from step 1 to any of the two original equations to solve for the other variable. So since we already have the first variable x, we are supposed to solve for the other variable, which is y. So I'm gonna label this as step 2 right here. So we're supposed to use any of the original equations that we have here. Now, we can see that it is good that we use this equation right here. Of these two original equation, it's faster that we use this part right here, which is y squared is equal to x plus 13 because we're looking for y. So then I can go ahead and use that over here. So I'm just gonna write this equation right here since we're solving for y. So that would be, we are going to use y squared is equal to x plus 13 to solve for y. So we are going to plug each of these into the this equation to solve for y. So then let's have the first one. So we let x is equal to the first one is negative 4. So then we are going to plug it in here. So rewriting this equation right here, this would come out y squared is equal to, again, when we plug in values, we always change it into a parentheses before we plug in values. So that would be a parentheses plus 13. Again, our x is negative 4. So then I can go ahead and say y squared is equal to positive 9. In order that we can solve for y here, we are going to use the square root property. Let a be any real number given that x squared is equal to a. X is equal to plus minus square root of a. So in this problem right here, we can go ahead and rewrite this as y is equal to plus minus square root of 9. So that the two values of y would be y is equal to positive 3. And so the other y would be equal to negative 3 because it's both positive and negative. So I can go ahead and write the points of intersection on the side right here. So I will label this as points of intersection. And please remember that if we say points of intersection, we are referring to the solution to this system, or this is... Okay, so the first point of intersection would be we have x is negative 4, so that's what we solved over here. X is negative 4, so I can go ahead and write negative 4. And then if x is negative 4, we have two values of y. It can be 3. And then if we have another negative 4, the other value for y is negative 3. So these are the first 2 points of intersection, that is considering the first x, which is negative 4. Now let's have the other points of intersection by solving for the other x, which is 3. So that's gonna be let x is equal to 3. That's the other x value. So I can go ahead and rewrite the equation right here. So we're using this equation for step 2. So then remember, when we plug in values, we always change the variable into a parentheses before we plug in values. So this would be y squared. Again, I'm using that. Y squared equals parentheses plus 13. Again, I'm using this one right here. I put that we're using this for the step 2. So then I plug in the 3 right here. So I put in the 3. So this would come out y squared is equal to 3 plus 13 is 16. And then again, we remember the square root property. Let a be any real number. Now x squared is equal to a. So to solve for x is actually plus minus square root of a. So in this problem right here, we can go ahead and rewrite this as y is equal to plus minus square root of 16. So there are two values of y. So the first y that we can have would be y equals positive 4 because the square root of 16 is 4. And then the other y value would be y is equal to negative 4 because it has to be both positive and negative square root of 16. So then we can go ahead and write the next point of intersection. So when x is 3, so I'm going to write 3. There are two values of y. We have 4. And then if x is 3, the other value is for y is negative 4. We actually have 4 points of intersection or 4 solutions to this equation. This means that these are the 3 points where these two graphs are touching each other, or these are the values of the x and y that would make this equation true. On the side, you will see the graph of the two equations, and it can be seen that these two graphs actually intersect at negative 4, 3, negative 4, negative 3, 3, 4, and 3, negative 4. Now, let's have another way of solving this. Now, I'm going to show you the other way, which is pretty much the same thing. The answers would still be the same, but it's just another option for you to have. So I wrote the same equation right here, and then I created this card right here. We are going to use this to explain the substitution method. Now, look at this. In the other example, I isolated the y squared. Now, others are going to say, what about if since x is already isolated by itself, why can't we just plug this into the x right here? We can also do that. So I'm going to show you the work on this. So the answer would still be the same. So let's start first by taking this y minus 13. So I'll take this, that is equal to x. So I am going to cover it to the x, but not the squared because this value is only for the x. So I will cover that up there. So then what happened is that this whole thing, y squared minus 13, was plugged into the x since this whole thing was equal to the x. We actually did part of the first step, which is to substitute or plug in one of the equation to the other equation and solve for the first variable. So what I did was I plugged in this part right here to the other equation. So I can go ahead and rewrite this as, that's gonna be the one that we plugged in, and then that's a squared. So that's actually x squared plus y squared is equal to 25. So then the one that I plugged in was the value for x, which is y squared minus 13, which is pretty much similar to what I did over here. So you see their setup is just pretty much the same thing. Now others are going to say, oh, you did not put a parenthesis on this, but there was a parenthesis on this one. Remember, when we plug in values, we always change the variable into parentheses before we plug in values. So then we can go ahead and simplify this. Now this one right here can be multiplied. Since this is a binomial, we can multiply this using the area models. I'm going to show the area model on the side right here. So then I can go ahead and rewrite this as y to the 4th minus 26y squared plus 169. That's this part right here. Then we continue to do the rest of them here. So that's plus y squared is equal to 25. So then we are ready to combine like terms. So the like terms that we have here would be negative 26y squared and the positive y squared, and that would give us y to the 4th minus 25 y squared. That's 25 because that's a negative 26 plus 1y squared would be a negative 25y squared, plus 169 is equal to 25. So then we use the zero product property, make one side equal to 0. So that's minus 25, and then that's minus 25. So that's minus 25 right here. So then we go ahead and cross the 25 out. So this would become 0. And this would come out y to the fourth minus 25y squared. And that's a plus. That's 169 minus 25 is 144. So then we are going to use the box and diamond for this. Now others are going to say like, oh, but that's to the fourth power. I'll give you a trick. It's pretty much like solving like that of a quadratic equation that is a trinomial. So then we can go ahead and write the diamond here. So what to write on the diamond? We multiply the first and the last. So that would be 144y to the fourth. And then this is negative 25y squared at the bottom. And so the factors for this would be, so we need to figure out what numbers, when we multiply them together, it's 144y to the fourth. And when we add them, it's negative 25y to the second. So that value is negative 16y squared. And the other one is negative 9y squared. So then we go ahead and draw the box for this. So then in the box, we write the first one right here, y to the fourth, and this is 144. And then the red factors that we got from the diamond, that is negative 16y squared, negative 9y squared. So then we can get the factors. This would be y squared and y squared. And then this is a negative 9. And this is a negative 16. So then these are the two factors. So I'm just going to go ahead and write that over here. So this becomes a factored form, which is y squared minus 16 times y squared minus 9 equals 0. So then from here, we can use the zero product property to solve for y. Y squared minus 16 equals 0, and y squared minus 9 equals 0. So then I'm going to add 16 from both sides, so plus 16 and plus 16. So then we are left with y squared is equal to positive 16. And we remember the square root property. So what are we going to do is we square root both sides. So square root this and square root this, so that we can go ahead and say that our y is actually plus minus square root of 16. So the two values would be y is equal to positive 4. That's the positive square root of 16. And then the other one would be y equals negative 4. That's the negative square root of 16. So these are the two values of y. Now we look at the other values of y right here. So we're going to add 9 from both sides. So plus 9 and plus 9. So then we are left with y squared is equal to positive 9. We use the square root property right there. So then our y is actually plus minus square root of 9. So then y is actually positive 3, because that's a square root, positive square root of 9 is positive 3. And then y is equal to the negative square root of 9, which is negative 3. So these are the values for the y. So then we can go ahead and move on to the second step. So our second step is to solve for the second variable by plugging in the values from step 1 to any of the two original equations. So then I can go ahead and label this as step 2 right here. We can use this equation right here. It's set up to solve for x. Since we already have the y, we're supposed to be solving for x. So we are going to use the equation which is x is equal to y squared minus 13, which is one of the original equations. So then I can go ahead and y is equal to 4. So then I plug this in here to solve for x. So that would be x is equal to, again, change it into parentheses, and then before we plug in values, so the value that we're going to put in would be 4. So then this would equal to x is equal to 4 squared is 16 minus 13. So then our x is 3. So we can go ahead and write the points of intersection on the side right here. So the other term for points of intersection is the solution. Okay, so the first solution would be when x is 3, the y is 4. So that's the one that we solved over here. So that's the first point of intersection. Now let's have the other points of intersection here. So we move on to, we already done with y equals 4. So then we go ahead and say let y is equal to negative 4. So then I do exactly the same thing. I use that equation right there. X is equal to, that's going to be changed it into parentheses before we plug in values. That's squared minus 13. Again, that is a negative 4 for the y. So I put a negative 4 there. So that is x is equal to negative 4 times negative 4 is 16 minus 13. So our x is positive 3. So then this is the second value for x. So I can go ahead and write that over here. So if our x is 3, the y was negative 4. So this is the second point of intersection. And I will do this for the rest of the y's here. So I'm going to show the work on the side right here. Okay, so the other set of points of intersection or solution would be this one right here. So if we have a negative 4, the y value would be 3. And if we have a negative 4 for x, the other value for y is negative 3. So pretty much these are the 4 points of intersection. What does it mean? If we graph this, these are the points where the two graphs would touch each other, or these are the x and y values that would make this equation true. On the side, you will see the graph of the two equations, and it can be seen that the two graphs actually intersect at 3, 4, 3, negative 4, negative 4, 3, negative 4, negative 3. So you get an option. It's up to you. You want to take this second method right here where we involve to the fourth power, or you want to take the first method. We only had second power. It's all up to you which method you are comfortable doing. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya.